Hello.
Hello.
Hello, sir. Am I
Yes.
audible?
Yes. Yes.
Okay, sir.
Okay. Another thing is it visible to everyone? Is this visible to everyone?
Yes, sir, it's visible.
Okay. So what I
Yes,
have said that
yes, sir.
in amplitude modulation, only the amplitude of the carrier wave is changed, while the frequency and phase of the carrier wave remain unchanged. Okay, it remains constant. Okay, so here you can see that this is your message signal, this is the carrier signal. The amplitude is changed, but the frequency and the phase is unchanged, only the amplitude is changed. Okay, so at the receiving end we receive this type of signal. Okay, so also it will be demodulated to get the actual signal at the receiving side. Now to transmit this signal will be transmitted. Okay, not we can get this one is receiving end side wave. Actually it is a combinations of my message signal and the carrier signal, so I need this signal only. Okay, because the information is in this signal, it is not in this position. Just to increase the power or energy or the frequency of this signal, we need to multiply this carrier signal with this message signal. Okay, and again to extract this original signal from this mixed up signal, we need to demodulate. Okay, so this is the general equation of amplitude modulation. Now consider this one is my oh, Shant Karanti. Okay. So AM, which is the which is the message signal actually, and here this is, please mute yourself. Okay, thank you. So AM equals to AM sine omega t, where this is the amplitude of my message modulating signal or the message signal. Uh, this is the frequency, and in the same way, if the carrier wave, it has the amplitude, carrier amplitude, and the frequency omega c. Okay, so the combination, so here all the parameters has been represented in this way. You can see it here. The aim is the modulating signal, a message signal. This is the carrier signal. The capital aim is the maximum amplitude of the message signal. So in this way, now the amplitude of the modulated wave, if A is denoted, then A can be written as the combinations of this one plus this one. Okay, here. So here, put the value of aim, the message signal, into this equation. We can get A equals to AC, the carrier amplitude, plus the message signal. And the instantaneous value of the amplitude modulated wave can be represented as sine theta, which can be represented as sine omega ct, the carrier wave. So from the equation 4 and 5, we can write it as A equals to AC plus AM sine omega mt, and under bracket then sine omega ct. Okay, so actually this is the equation of my modulated wave. Okay. A equals to AC plus AM sine omega t within bracket, that is sine omega ct. So that is the actual amplitude modulation wave equation. Now to get the sideband frequencies, this one, So again, consider this modulated wave signal, where we can calculate the modulation index, as we have already seen in this lecture, the modulation index, which is AM by AC, the modulated amplitude divided by carrier amplitude signal. Okay. So here AM, which is equal, so this is, if you can check it through this diagram, this is the A max, the maximum amplitude. This is the carrier amplitude. So this is my actual wave, modulated wave with the equation is AC plus AM sine omega nt. This is the only modulated wave. Okay. And this one is again AM, the message signal amplitude, and this is the minimum position where we can get the minimum amplitude, okay, in the message signal. So now we can write it as AM can be written as maximum amplitude minus minimum divided by 2. Okay, this one. And we know that the carrier amplitude is equivalent to the maximum amplitude minus AM. So we can get the actual AC, the carrier amplitude. So put this value, AM value, from this value into this equation, we can get the carrier amplitude equivalent to this one. Okay, so taking the ratio of equation this one and this one, AM by AC, we can get the modulation index, which can be represented in this way. And finally, this modulation index for amplitude modulation for AM, the modulation index should be this one, A max minus A min divided by A max plus A min. Okay, so this is the modulation index. We can calculate it from the modulated wave. So modulation according to some depth of the modulation concept, modulation index concept, we can categorize this one as perfect modulation or under modulation or over modulation. Okay, so you can see in this picture there are three types of modulation depth. This is the perfect modulation where the modulation index is equals to 1. This is the under modulation where modulation index is less than 1, the value. And this is the over modulation where modulation index is greater than 1. Okay, so there are three types of condition. Now if we consider the perfect modulation, this is the first thing, where it occurs when the maximum amplitude of the message signal or modulating signal is exactly equal to the maximum amplitude of the carrier signal. That means AM is equals to AC. Capital AM is equals to AC. At that time, we can get this perfect modulation. Now, the modulation index is the ratio of the maximum amplitude of the message signal to the maximum amplitude of the carrier signal. Okay, for example, if we consider the message signal maximum amplitude is 4 volt and carrier signal maximum amplitude is of so 4 volt, then the ratio of the modulating signal amplitude will be uh, it is divided by 4 divided by 4, which is equals to 1. Therefore the modulation index in perfect modulation is equal to 1. Okay, and that is the condition here. In this way it is modulated. But when mi, that is the modulation index, is less than 1, what happened? That is called the under modulation. Okay, so here the modulation index is also known as the modulation depth. Okay, the perfect in this perfect modulation, it is the depth of 100%. So the carrier level falls to 0 level. So perfect modulation causes no distortion. Okay, it is reaches to the 0 level. Okay, under modulation here, it occurs in the when the maximum amplitude of the message signal or modulating signal is less than the maximum amplitude of the carrier signal, which means AM is less than AC. Okay, so the modulation index is the ratio of the maximum amplitude of the message signal to the maximum amplitude of the carrier signal. Here also, if we have considered the same type of example, like message signal maximum amplitude is 2 volt and the carrier signal maximum amplitude is 4 volt, then the ratio of modulating signal amplitude 2 volts to the carrier signal amplitude 4 volt is equals to 0.5. Okay, so therefore the modulation index in this under modulation is less than 1, which is 0.5. So it is so we can say that the modulation depth is less than 100% in this case. Okay, and in so the carrier level falls above 0. Okay, and same it causes no distortion. But in case of if mi means modulation index is greater than 1, then it is called the over modulation, because the maximum amplitude of the message signal or modulating signal is greater than the maximum amplitude of the carrier signal. Okay, same example here. If the message signal amplitude is taken as suppose 6 volt, okay, and the carrier signal maximum amplitude is 4 volt, then what will be the modulation index? That is 1.5. Okay, so the modulation index in this type of over modulation is called it is called the over modulation. It is the greater than 1. Modulation index is greater than 1. Okay, and we can say it is the modulation depth. Modulation depth is of greater than 100%. Okay, so here in this case the carrier wave experiences 180-degree phase reversals, where the carrier levels falls below the 0 point. Okay, so there will be certain distortion. Okay, and due to this distortion there may be some data loss. So over modulation is one of the reasons why amplitude modulation is no longer used to transmit high quality sound signals. Okay, at the transmitter limiters are included which prevent more than 100% modulation. So it prevents the 100% modulation. So that's why one limiter will be used. Now, if we consider the frequency spectrum, how can we get this frequency spectrum using the previous equation, which is the general equation of amplitude modulation wave equals to AC plus AM sine omega t sine omega ct, where we can say that mi modulation index is AM by AC, and hence we can calculate is AM equals to is equal to mi into SE. So putting this value into this equation, we can get this one. Okay, and how can we simplify it using the normal equation? Sin A sin B formula can be implemented here, so we can get actually A equals to AC sin omega ct plus AC modulation index half cos omega c minus omega ct minus omega in t minus AC in modulation index half cos omega c plus omega in t. Okay, so here in this equation the first term it represents the unmodulated carrier signal. Okay, which carrier signal is combined with the message signal. So this is the carrier signal, and the second term, this one, is represents the lower sideband. Okay, and this is called the upper sideband. Okay, lower sideband and upper sideband. Okay, Now here omega c can be written as 2 pi fc and omega m can be written as 2 pi fm. So if frequency is it is converted into frequency form, so two side frequencies are available. This can be calculated in this way, where this represents the lower sideband frequency, this f, and here the upper sideband frequency. This fc minus fm is called lower sideband frequency, and this fc plus fm is called the upper sideband frequency. So here this is your actual amplitude. Okay, of the carrier signal. This is the actual amplitude of the carrier signal, and this is the upper sideband. This is the upper sideband, and this is the upper sideband frequency, fc plus fm, and this is the lower sideband frequency. Okay, and it is the carrier frequency, and this upper sideband frequency and lower sideband frequency will not be the equal amplitude of this carrier wave amplitude. It will always be the half of this one. Okay, this two frequency band will be always half of this AC. Okay, and using these two sideband frequencies, we can easily calculate the bandwidth. The bandwidth of the signal can be obtained by taking the difference between the highest and the lowest frequencies of this signal, and we can get it is here. So the total bandwidth will be 2 fm. Okay, it can obtain the bandwidth of the m in this way. So this is the frequency spectrum and bandwidth calculation of amplitude modulation technique. So now these certain advantages and disadvantages are there for amplitude modulation technique. So advantages are few components are needed uh, at the receiver side. The original signal is extracted or demodulated using a circuit consisting of very few components. Okay, the cost will be minimized. Okay, so the components used in amplitude modulation is very cheap. AM transmitter and AM receiver build at very low cost, so the total communication system design cost will be minimized, and it is simple to implement, and long distance communication purpose it is used. uh, Disadvantages are amplitude modulation is inefficient in terms of power usage, because as we know that the message signal contains information, whereas the carrier signal does not contain any information. Okay, now in amplitude modulation, what happened, most of the power is concentrated in the carrier signal, which contains no information. Now, at the receiver side, the power consumed by the carrier wave is wasted. Okay, so that's why it is inefficient in terms of power usage. It requires high bandwidth. The amplitude modulation is not efficient in terms of its use of bandwidth. It requires a bandwidth equal to twice that of the highest audio signal frequency, as we have seen in this case, 2 fm. It's twice we need. Okay, so high bandwidth is required. This type of transmission can be easily affected by the external radiation, and also it is affected by man-made noises or radiations like waves from other antennas or other channels. So distortion will be more in this technique. And amplitude modulation cannot be used for transmission of sensitive information, like in case of defense, where interpretation or loss or disruption during transmission is not an option. Okay, so it is not used in emergency purposes. Different applications are also there for amplitude modulation, like air band radio. It can be used the amplitude modulation. It is used in aerospace industry, like very high frequencies transmission made by the airborne equipment still use amplitude modulation. The radio contact between ground to ground and also ground to ear uses this amplitude modulation signals. Okay. The second is the broadcast transmission. So it is still widely used for broadcasting either short or medium or long wave bands because of cost, low cost. Okay. Quadrature amplitude modulation, where it is used in the transmission of data of almost everything from short range transmission such as Wi-Fi to cellular communications. Okay, so in quadrature amplitude modulation is formed by mixing two carriers that are out of phase by 90 degree. That is quadrature amplitude modulation. And single sideband. So the amplitude modulation in the form of single sideband is still used for high frequency radio links. It is used. Okay, so these are the applications where you can use the amplitude modulation. Okay, so that's all for today. If you have any queries, any doubts, you can ask me. Anyone. If you have any queries, any doubts. Any doubts?
No, sir.
Okay. So switch on your videos to give the attendance. Everyone ready for attendance? Roll number 6, Vishnu. Roll number 6. 7, Tirtho. Roll number 7, Tirtho. Roll number 8.
Yes,
Roll number
sir. Yes, sir.
yes. Roll number 9.
Present, sir.
10.
Present, sir.
11.
Yes, sir.
12.
Yes, sir.
13. 13. Shubham Gorai. 13. Shubham. 14. Roll number 14. Shubhajit Bose. Shubhajit Bose. 15. Shubhajit Bera. Okay. Marked. Roll number 15. Done. 16. Roll number 16.
Present, sir. Hello.
15 marked. 16.
16, sir.
Done. 17. Okay, 15 and 16 you can switch off your videos.
Okay, sir.
17. Saurabh Ghosh.
Yes, sir.
Okay.
Yes, sir.
Roll number 18. Somo Majumdar. Somo. Roll number 19.
Yes, sir.
20. 21.
Present, sir. 21.
22. Shaunak Bose. 22. Shaunak. 23. Shayandeep Gorai. Shayandeep. 25. 25. Shotopriyo. Sottopriyo 25. 26 Sottom Anand 26. 27 Roshan Kumar 27 Roshan Kumar.
Yes, sir. 27.
28
Sir, 27.
27 marked. 28 sorry 29 Ritankar. 29 Ritankar. 30 Ritam Majhi.
Yes, sir.
Hmm.
Yes, sir. 30.
Yes. 32 Rishabh. 32 Rishabh. 33 Rahul.
Yes, sir. 33.
35
Present, sir.
36 Pratiti. 36 Pratiti. 37
Present, sir.
38
Present, sir.
39
Yes, sir.
40 roll number 40 Pallavi Singh. Roll number 40 Pallavi. 41 Wendrila. 42
Yes, sir.
Ishant. 43 Nirmallo.
Sir, 42, sir.
Done. 42 done. 43 Nirmallo. Done. 44 yes Nirmallo marked. 44 Neha. 44 Neha. 45 Mithilesh. 46 Irshad. Mohammad Irshad. 46 Mohammad Irshad. 47 Kaustubh Trivedi. 48 Karandeep.
Yes, sir. Yes, sir.
Okay. 49 Jyotirmoy. 49. 50 Karandeep, switch off your video. Roll number 50.
Yes, sir. Done.
Himanshu. 50.
Sir, present. Sir, present.
Okay. 51 roll number 51 Ishani. Roll number 51 Ishani. 52 roll number 52 Diptendu. 53 Devjit Adak. 54
Present, sir.
okay. 55
Present, sir.
54 done. 55
Yes, sir.
56
Present, sir.
57 Arnob. 57 Arnob Devnath. Arnob. 58 Orko Mitra. 59
Present, sir.
60
Present, sir.
61
Yes, sir.
62
Yes, sir.
63
Present, sir.
64
Present, sir.
65 Sudipto. 65 66 Rishin Bose. 66 68 Avantika.
Present, sir. Present,
Okay.
sir.
Roll number 1 lateral 1 Tanushree.
Present, sir.
Lateral 2
Yes, sir.
lateral
Yes,
3
sir.
lateral 3 Moinak. Okay, anyone else?
Hello, sir. 62.
Sir, 12 before again I have
62 done. 12 done.
So 50.
50. Yes, done. Okay, so thank you everyone. I'll end this meeting.
Thank you, sir.
Thank you.